So you started talking about the new chip, and of course, there's actually a forum that's on another site where they're talking about what you've heard about the new chip. Is there anything you want to tell the world about the new chip that you're working on?
Yeah, it's gonna. Right now, we're planning to put 256K of RAM in it, which is 8 times what the current propeller has. So you'll be able to do graphics a lot better than you can right now. There'll be a lot of room for full-screen bitmap graphics. Also, the cogs themselves are going to be much faster. They'll probably execute code at about 10 times the rate because of the pipelining and 4-port cog memory. And then also each cog has a Cortex system built into it. I don't know if you guys have learned about Cortex, but it was this invention, this kind of numerical scheme some guy came up with in the 50s for doing nautical navigation, and it's just it's a system of coordinate rotation where you piecewise just shift add, and it allows you to do things like polar to Cartesian, Cartesian to polar, and you can also, by using a different lookup table for the angle, you can, what's the angle in circular functions, you can do logarithm and exponent functions. So between the circular functions and log and exponent, you have like a toolbox to do all kinds of DSP stuff. So that's going to be in the next chip. Also, we'll have a single cycle multiply instruction. Thinking about putting some kind of divide hardware into it. Divide is a real pain because you have to perform tests. It's not a completely like deterministic process like multiplication is. So the hardware is always a little bit slower to divide, but might put something like that in there. Maybe a square root function, and then also a lot of kind of bit rearranging operations. So like you can take 32 bits and then, rather than just shift them or something, you can like take all the even bits, even position bits, and put them in the, say, low word, and all the odd position bits, put them in the high word, and other transforms to facilitate maybe like Manchester encoding or decoding, these kinds of things.
Cool. Yeah, it seems like with the propeller, it's like, I mean, you used some of the lessons learned from the microprocessor industry, but it was kind of like clean slate. And how would you do it if you wanted to keep things really clean, simple, and fun, as you said? Is that true? I mean, it really just seems like just a redesign of the whole idea and the model.
Yeah, it was a really iterative process. I mean, it was like 10 steps forward and 9 steps back all the time. And so what wound up being the propeller was, it took 8 years of time, and it was really exhaustive, but I feel like it turned out just right. It turned out to be what it, everything it could have been. But we started out, go ahead, Al.
Oh, no, I didn't say anything.
We started out making the chip. I just got some chip design tools, and it was kind of kooky. I just started like designing gates and everything, and that wasn't really going to get us anywhere. And some salesman came through here who represented Altera, and they make these big FPGA chips. And he got me started on these Flex 10K chips, and now we're using the Stratix 2, and we're going to start using the Stratix 3. But these things are awesome. They're just like putty. You can try out any kind of logical design in these things and put it all out. So I use this to really hammer out the architecture. And this was I spent years just, probably 5 of those years just playing around with the FPGA and doing all of our concept design on those and proving everything out. And then at the very end, I took that code. We used AHDL. Altera, you can program in VHDL or Verilog, their own little homebrew language, which is real simple, called AHDL. And I really like AHDL because it doesn't make any, kooky inferences or anything like Verilog seems to for flip-flop. It's very direct. And so AHDL translated very nicely into schematic form so that we could then design the chip. So after the logic had been proven on the FPGA, I took all that and then designed all the blocks in kind of standard cell form to fab the chip in, and then, you know, amassed all the blocks together in a way that made the logic for the chip. And then there was also some analog stuff designed, like phase lock loop, which has a VCO in it, which that alone, I probably spent 9 months just playing around with the VCO design. VCOs are pretty neat. You know, you put a little logic around them and get a phase lock loop. But it all took a lot of time, and it was very iterative, but it turned out in the end to be just, you know, what we wanted to make. And I don't know, it's probably not perfect for everybody, but at least it does a lot of stuff. It's easy to use, it's kind of fun, and it's simple, and it's really designed to be understood. That's like a big deal, because a lot of these chips these days, they have these dark corners in them that are not documented very well that the design engineers know about. They might have served some kind of internal purpose during development, but the customer is not really to even know about it. In fact, it's even worse than that oftentimes, because they'll even hide the hardware of the chip and wrap up the functionality in some code module that you're supposed to use to interface to it. Because that's how the PC works these days. The video hardware is from one card to another might be wholly incompatible because the driver smooths out all the differences. And so I think some of that's creeping into microcontrollers these days. But the propeller chip is designed to be thoroughly understood. There's not a bit in any register that is not thoroughly documented. It's meant to be understood by the person programming.
Cool. That's the other question?
What is your educational background that got you started? I mean, have you gone master's, PhD level, or?
I love this answer.
No, I barely got out of high school, and then I went to our local junior college for a while because my parents and girlfriend at the time were just convinced I was going to wind up being a real loser if I didn't get educated. So I went to our JC for a while, and I just wasn't really into it. I remember a lot of the chemistry class, that was pretty good, but otherwise I wound up with like 0.95 GPA, and I was going to be on academic probation, and I just kind of fell out at the bottom. And you know, Parallax had already been started before I went there. The activity level wasn't really high yet, but it was still something to do, and I had been doing electronics since I was 12 or so. Even before that, really, computer stuff was about 12. So I just sort of shifted more to that, and that's where my energy went, and then Parallax slowly grew. But I don't have any credentials to speak of.
You know,
Also,
it's kind of interesting. Engineering schools are finally going to what they call project-based learning now, which in this class we don't have any homework, we don't have any exams. In lecture we learn about what we're going to do in lab, and then we go to lab and we write code and we do it. It's more project-based, and I think that's simply, I mean, with your experience, if you have some goal that you want to get to, and you go get the books out of the library and you figure it out, you get on the internet, you learn much more than if you.
Oh yeah, that's how you learn. You have to have some goal, something you want to do, and then in pursuing the goal, everything falls into place. And I've learned things about signal processing that were probably like, you know, post-grad semester courses that I picked up in maybe a month or so just out of necessity. I don't know that. I can't say that with certainty, but I suspect that. But I had to, like, I walked all the way up the staircase from the bottom floor, and a lot of people, like when I first started seeing chips being designed over at Phoenix Semiconductor, which is now called Cubicom, and we sell their SX chip, they had all these chip designers that really had no concern about the intent behind what it was they were designing. It's like they took an elevator and they got off at the top floor, and they didn't know what was underneath, and they didn't care. It didn't matter because they just, fulfilled their requirement for their job they were doing, and that was it. And then they went and thought about whatever else they wanted to do on their own time. But me, I've always been really interested in all the, inner workings and all the intermediate stages of how everything works. But that's not really how the industry works. There's a lot of specialists.